Okay, so now let's look at another example. It's a definite integral problem, and it asks us to evaluate this integral by using substitution prior to integration by parts. Okay, so that's just the problem requirement. Okay, so for the u substitution, we can set u equals 12 minus x, then du equals negative dx. It's pretty common. When x equals 0, u equals 12 minus 0, which is 12. When x equals 12, u equals 12 minus 12, which is 0. Okay, so when we have this, we can set up our integral, which is from 12 to 0. And we can solve x in terms of u, because we need an x here. So x is going to be 12 minus u. Okay, so it's 12 minus u times square root of u. And then also du equals negative dx. So dx equals negative du times negative du here. So this is what we have so far. Okay. And so we can write as 12 to 0. We can distribute this negative to here. Then it's going to give us is u minus 12, right, times square root of u du. As you can see here, guys, for this problem, after here, you can directly integrate it, okay, without using the integration by parts, okay, without using the integration by parts. Okay, but the problem says we are using the integration by parts. So I think I made something a little bit confusing because the notation here. Okay, so let's change our notation from here. Let's change the notation from u to, let's say, to t. Okay, why? Because you know, when you select use the integration by parts, you're gonna select u, you're gonna select v prime. That's a different u, so I just want to be clarified. So the problem is 0 to 12, say t minus 12 times square root of t dt. Okay, so now you want to make the integration by parts. So if we set u equals t minus 12, okay, and then if we set v prime equals square root of t, okay, equals square root of t, and it turns out the u prime equals 1, right? And then the v, so this is the t to the power half, right? So you just integrate it, it will give you t to the power 3 over 2, and then you have 2 over 3. Okay, so that's our v here. Okay, so apply the integration by parts for this definite integral. It will be u times v, which is t minus 12, times 2t to the power 3 half over 3, evaluated from 12 to 0. Okay, and then minus the integral from 12 to 0. So it's u prime times v, which is just 2 t 3 half over 3 dt. Okay, and okay, so it turns out this interval is so easy to evaluate, right? This part, if you plug 0, this part is 0, gone. You plug 12, this part is 0, gone. So it's 0 over 0. In other words, this purely equals just this part. Okay, so this equals, well, maybe right here. So this part is 0 minus, the interval for this is going to be 2 over 3 times t to the power 3 over 2 plus 1 over 3 over 2 plus 1. And evaluate from 0 to 12. Okay, from 12 to 0. So turns out you can do some simplification, I believe. So this can be, let's see, you have 2 over 3 times, this part going to be 5 over 2, right? So if you flip it, it's going to be 2 over 5, okay. And time t to the power of 5 over 2. And then minus from 12 to 0. So it turns out this is going to be negative. So if we plug 0, this is 0, right? Minus, well, this is going to be 4 over 15 times 12 to the power of 5 over 2. Okay. And it turns out the final answer for this is going to be, well, 4 over 15. Okay. This part, 12 to the power of 5 over 2, can be treated as 12 squared times 12 to the power of half. Okay. So this part is 144 times this. Ooh, this is going to be 576 over 15 times square root of 12. Okay, so yeah, I've finished the problem. Hope you enjoy this video.